Good morning to all. Today we are going to give an introduction to our 5th semester topic, differential equation. Many of the general laws of the nature, physics, chemistry, astronomy, etc. are expressed in the language of the differential equation. For example, Newton's second law, acceleration of a body of mass m is proportional to the force acting on it. That is, F is the force, m is the mass and a is the acceleration. Then F is equal to m into a. We know that acceleration is the rate of change of velocity. So, force is equal to mass into acceleration, the second derivative of the displacement x. So, this is a differential equation. So, what is meant by a differential equation? Let us recall the basic definition of a differential equation. The differential equation is an equation involving one dependent variable y and its derivative with respect to one or any number of independent variables. I repeat it again. Differential equation is an equation involving one dependent variable, say y, and its derivative dy by dx, where x is the independent variable. So, an equation involving y and its derivative is known as differential equation. For example, dy by dx plus gy is equal to 0 is a differential equation. Then we have to define what is the order and degree of a differential equation. Order and degree of a differential equation. If y is a function of x, where x is the independent variable, y is the dependent variable, we differentiate this y with respect to x. So, dy by dx, it is the first derivative. Now, again differentiating d square y by dx square, this is the second derivative. Differentiating again dq y by dx cube, this is the third derivative. Now, we have to consider the differential equation d square y by dx square plus 5 dy by dx the whole square plus 6y equals 0. If we go through this differential equation, here the highest derivative is d square y by dx square. So, the order of the differential equation is the order of the highest derivative. Here the highest derivative is d square y by dx square and its order is 2. It is a second order differential equation. So, order of this differential equation is 2. The reason, it is the order of the highest derivative. And here the degree of the differential equation is the degree of the highest derivative. Here also again this is the highest derivative and its degree is 1. So, the degree of this differential equation is 1 and order is 2, even though a term containing second degree is there, but it is not the highest degree term. This one is the highest degree term. We go through another example. d4y by dx raised to 4 plus 6 dy by dx the whole cube is equal to 8y. Here this is the highest derivative and its order is 4. So, order of the differential equation is the order of the highest derivative. So, order of this particular differential equation is 4 and its degree is 1. Here degree is 1 and order is 4 for this highest derivative. Then we define what is meant by an ordinary differential equation and what is meant by a partial differential equation. Ordinary differential equation means a differential equation which have only one independent variable. For example, dy by dx plus ky is equal to c. It is a differential equation. Here is only one independent variable x. Y is a function of x. We have y is the dependent variable, x is the independent variable. Since there is only one independent variable, such differential equation containing one independent variable is known as ordinary differential equation. Ordinary differential equation. Now, what is meant by partial differential equation? For partial differential equation, there are more than one independent variable. For example, y is a function of x and t. Two independent variables are there, x and t. Whenever two independent variables are there, we have to differentiate this partially. What is meant by partial differentiation? Dy by dx, partial dy by dx means we differentiate y with respect to x, keeping the other independent variables as constant, say for example t as a constant, and partial dy by dt, which means we differentiate this function with respect to t, keeping x as a constant. So, this is the partial derivative of y with respect to x, simply yx, and this is a partial derivative of y with respect to t, yt. So, differential equation involving partial derivatives, for example d square y by dx square plus 5 into partial dy by dx plus 6y equals 0. This is partially ordered differential equation, partial order differential equation, and this one is ordinary differential equation. Now, we are giving some examples to find the partial differential equation, order of the differential equation, and the degree of the differential equation. What is the degree of the following differential equation? Example: d square y by dx square plus 5 dy by dx plus 6y equals 0. Here the differential equation have order 2 and degree 1. Another example: dy by dx plus y is equal to root of 1 plus y2 dash the whole square. In order to find the order and degree of the differential equation, we have to remove this radical sign. How can we remove this radical sign? Removal of the radical sign is only by squaring both sides. When we square this term, this becomes dy by dx plus y the whole square equals 1 plus y2 dash square. Now we find what is the degree and order of this differential equation after removing this radical sign. Here this is the highest derivative, y2 dash. y2 dash means d square y by dx square the whole square. So, order of the differential equation is 2 and the degree of the differential equation is also 2. Now, we define the solution of a differential equation. What is meant by solution of a differential equation? Consider the differential equation dy by dx minus d square y by dx square minus 5 into dy by dx plus 6y equals 0. It is a differential equation. This can be written in the form y2 dash minus 5y dash plus 6y equals 0. The solution of the differential equation is a function of the form y is equal to f of x, which satisfies this differential equation. A function of the form y is equal to f x, which satisfies this particular differential equation. So, for this differential equation, if you take y is equal to e raised to x, what happened? When y is equal to e raised to x, y dash is equal to 2 into e raised to x, y2 dash is equal to 4 into e raised to x. So, substituting this value there, instead of y2 dash, we have 4 into e raised to x, minus 5 into y dash 2 e raised to 2x plus 6 y. What is y? E raised to 2x. Simplifying, we have 4 e raised to 2x plus 6 e raised to 2x, that is equal to 10 e raised to 2x minus 5 into 2, 10 e raised to 2x. This is equal to 0, which means y is equal to e raised to 2x is a solution of this particular differential equation. Here is one more solution is there. If y is equal to e raised to 3x is also a solution. Y is e raised to 3x. So, y is equal to e raised to 2x is a solution. Y is equal to e raised to 3x is another solution. So, these two solutions are known as particular solutions. Particular solution. If we combine together, y is equal to c1 e raised to 2x plus c2 e raised to 3x. If we check, this is also a solution of this differential equation. So, these two particular solutions combined together or written as the linear combination of e 2 raised to x and e raised to 3x, then that is again a solution of the differential equation. So, this type of solution is known as general solution of the differential equation. When we are giving particular values say 2x and 3x is particular solution, and the combination of these two particular solution become the general solution of a differential equation. So, here we define first of all what is meant by a differential equation. Differential equation is an equation involving one dependent variable and its derivative with respect to a number of independent variables. Then we define the order of the differential equation. Order of the differential equation is the order of the highest derivative. Degree of the differential equation is degree of the highest derivative. So, these are good morning to all. Today we are going to give